Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Iskandar bin Ishak, student of Mechanical Engineering. Will be presenting to you about my final year project, which is the computational fluid dynamic simulation on the online storage Sri RAMPAI for the Rancangan Tebatan Banjir Sungai BUNUS. So let's get started. So my final project has been supervised by Dr. FIRDAUS MOHAMAD, my supervisor, and my co-supervisor Dr. Zulkifli Mohammed, Associate Professor, Technologies. Let's move to the project summary for my final year project. So flood is a natural calamity that occurs frequently over the world. Malaysia is the one of the countries that is influenced by the monsoon season every year. The approach for dealing with the flood hazard has to be revised. The simulation will be done using ANSYS software, and the analysis can be done using the computational fluid dynamic methods. The finding of this study will be significant because they will be used by Jabatan Pengairan dan Saliran JPS to improve the present flood mitigation plan. We will be moving to the introduction of my project. So the primary causes of floods is the large amount of rain in river catchment areas and areas with insufficient drainage. So according to Jabatan Pengairan dan Saliran, flood mitigation plan RTB in Kuala Lumpur is currently only at 85%. So with that, the Jabatan Pengairan dan Saliran needs the data of the rate of water discharge at the online storage Sri RAMPAI. So for this project, we will be using the computational fluid dynamic CFD methods. We will be using the ANSYS software for my project. Next, we will move to the problem statement. So first, we have the discharge of water need to be less than 10 meter cube per second in order to prevent any risk of flooding. From this study, the flow rate of the water, the future impact of the water behavior, the recommendation of the update of the current control measures, and to explain the risk will be done from this study. Next, we will be moving to the objectives part. So the main objective for my project is to avoid flooding at Lencongan Kampung Baru according to Sungai BUNUS Flood Mitigation Plan RTB. And then we have the sub-objective for my project, which is to identify all the parameters, conditions, calculation of the CFD simulation. And then I want to simulate the discharge rate of the water at the online storage Sri RAMPAI. Next, we will discuss about literature review. So first, I have studied about flood from M. Tanoe's article. M. Tanoe said that flooding can be classified into 5 different categories, which are the river flood, coastal flood, storm surge, inland flood, and the flash flood. The consequences of this flood left country with insignificant financial losses as well as widespread devastation. So next, we have the literature review for the flood mitigation plan, which has been written by T.S. Amjad Babu. So T.S. Amjad Babu said the governments of the countries in Southeast Asia have taken a variety of actions to combat climate change. When it comes to reducing the risk of flooding, flood mitigation projects or flood mitigation plan such as levees and dams are the most frequently used technique. Next, we have the open channel flow, which is written by the Ishak. Ishak said that the open channel flow are the flow structures that have a free surface that is exposed to the surrounding environment, and then even for the channels with basic geometry such as rectangles, these open channel flows will reveal a complex flow structure that is difficult to understand. So next, we will discuss about the scope of work for my project. this simulation is based on two distinct wind speed scenarios, which is first we have the when the wind speed is regarded to be insignificant, which is 0 meter per second, and then we have the wind speed during a heavy downpour or during heavy rain, which is around 5 meter per second. So there are three variables involved in this study, which is the wind speed during a heavy downpour or during the heavy rain, the upstream and downstream of the water levels, and last but not least is the discharge capacity based on the average rainfall intensity RE. And then the NC software will be used to perform a 3D computational fluid dynamics simulation. We're moving to the limitations of my project. First, we does not consider the secondary flow due to the sediments within the river. So you can see in the slides here, this is the sediments of the river. So we didn't consider the secondary flow that causes by this sediment. Next, we have another limitation that causes by the NC's student version, because this NC software has the student version that has limits the processing of the elements and nodes, which is 512,000 of element and nodes only. Next, we will go to the most important part, which is the methodology. So you can see here, my methodology has been divided into five categories, which is the gathering information, 3D simulation, collect and analyze data, discussion and conclusion, and last but not least is the report writing. So for the first methodology, we will be using the gathering information. So this gathering information accomplished through the self-revision of journal articles, book chapters and other published material that have been published within the last 10 years. And some data have been provided by Jabatan Pengairan dan Saliran, such as the layout plan and the depth of the river of the Sri Rampai River. Okay. For the second methodology, we have the 3D simulation. This 3D simulation has been divided into 4 different parts, which is first we have the sketching. So the 3D sketch has been drawn on any XY plane, ZY plane or XZ plane by using space claim that is already connected with my NC software. Next, we have meshing part. So this meshing part, we will import the 3D model from this space claim into the NCs and start meshing the models. Next, we have the pre-simulation validation. So the turbulence model employed in the simulation is then validated using the simplest mathematical equations after the investigation. So the open channel flow will be handled with the volume of fluid formula. Okay. So for the fourth part of the 3D simulation, we will be executing this part using the Fluent software from NC software, and then the simulation of the turbulent fluid flow is accomplished by use of the Reynolds average Navier-Stokes runs equation. Next part, we have the collect and analyze data part. So the data and the result from the simulation is going to be noted and analyzed. Next, we have the discussion and conclusion. So there will be some conversation that will need to take place in order to evaluate and determine any possible errors as well as the accuracy of the simulation that has been performed. Last but not least, we have the report writing part. So all the material gathered during the research will be compiled in the form of technical report and thesis, which will be used for the future research. Dear panels, we have come to the last part of my presentation, which is the preliminary result. The discharge rate obtained from my study will be analyzed in order to confirm the discharge rate from all the storages will not exceed the maximum capacity of the Rancangan Kapur Baru, which has been told around 10 meter cube per second. So it is projected that increasing wind speed will result in an increase in the discharge rate of the water at any storage in Kuala Lumpur. So that's all from me. I'm Iskandar bin Ishak. Thank you for listening to my presentation. Have a good day. Thank you.